All right, let's wrap things up here. So here's the table, all filled out. Check your numbers, make sure everything looks right. So 2, 7, 13, 12, 7, 3, and then check those cumulative relative frequencies. And here's our percentiles. Here's how that connects back to percentiles that we were talking about with Mackenzie just a little bit ago. So to make an ogive, probably the sweetest name for the graph types that we've used for sure. Here's what we should have. So at 40, gives a little explanation in the description again. But at 40, that's the 0th percentile. There were 0 presidents younger than 40. Um, and at 45, there was our value that we got in the 40 to 44 class. 4.5% is the percentile. 4.5% of all presidents were younger than 45, and then keep going up like that. So at 50, we have the 20.5 or whatever that was. At 55, we have 50%, and so on, all the way up to 70, where we get 100% using this data set. So there is our fantastic ogive. Make sure to have a well-constructed ogive. You should have scale-appropriate labels. I ignored my own advice and did not give it a title, but I should give it a title, and I don't think there's a key necessary at all on this. So now on the backside, using just the ogive now. Let's pretend like we didn't know the data set to begin with, and all we have is the ogive. Let's make sure we are able to read and interpret the ogive and be able to answer questions with it. So question number 1 was Barack Obama, who was first inaugurated at age 47, unusually young. Well, at that age of 47, he's right here. If we go up until we hit the ogive and then go over to the other axis, we get to 10. About 10% of all presidents were younger than him at the time of their inauguration. Yeah, I'd say that's pretty unusually young. Number 2, estimate and interpret the 65th percentile for the distribution. 65th percentile is right here. Go over to until you hit the ogive, then go down. We get an age of approximately 58. So there is our estimation. About 65% of all presidents were younger than 58 years old. Number 3, describe how you could estimate the percent of presidents who are between 55 and 59 years old at the time of their inauguration. So at 55, we're right here. And at 59, we're right here. Find the difference in the heights at those two spots. So at 50, at 55, we're at the 50th percentile. At 59, we're at roughly, go over to 60. We're looking for 50 to 59. At 60, we're at 77. So find the difference in those cumulative relative frequencies. And we get roughly 27% between those two values. All right, last one. Describe the last one before the multiple choice thing. Describe the distribution using SOX. Here's what we should end up getting. Shape is pretty symmetric. Now, looking at this ogive, it certainly looks pretty skewed to the left, doesn't it? But the data set itself, if we look at the frequencies, looks pretty symmetric. Looking at the relative frequencies, looks pretty symmetric. I'll show you a different way to think about that in just a minute here. But it is pretty symmetric, not skewed to the left, which seems kind of strange. Shape is really kind of hard to see in ogive, but I'll show you how we can think about that. Outliers, it doesn't appear to that we have any outliers. I'll show you how else we can think about that just on the ogive as well in a moment. Center is 55 years old. We can see that center, median, 50th percentile. Here it is. Halfway point of the data set. That happens at 55 years old. And then the spread, that very last part, is about 27, 69 to 42 years, or roughly 40 to 70 that we can see in the ogive as well. All right, last couple questions. Not using the president data anymore. Multiple choice. We should have got C. Mark did better than about 68% of the students, and then number 6 was pretty similar to the Mackenzie case that I had just a little bit ago as well. So her daughter's heavier than 87% of the girls her same age, and taller than 67% of the girls her same age. All right, so I'm gonna go back to the presidents again, and I want to think about shape and outlier for just a moment here. So, thinking about an outlier, that would mean that here's all the data, and then there was one weird thing. Let's say we elect a president who's like 95. 20 years from now, Hillary decides she wants to run one more time, and sure enough, we elect Hillary. She's 95 years old at the time of her inauguration. Well, what happens from 70 all the way to 99? There's not any data in there. So we just see this flat spot, nothing, 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 and then something. So if we level off for a long time and then just have that one little jump at the end, that would indicate that we have an outlier present way out here. And then the last thing, the shape. Um, we should be able to take this ogive and make a histogram out of it. And the first bar is fairly simple. Start at 0, go up until we get to this other one over here. There's our first bar. From there on out, it gets more complicated because now I need to think of how much stuff is between 45 and 50. Well, it'd be the difference between this one and that one. And then the amount of stuff between 50 and 55 is going to be the difference between here and here. And then the difference from 55 to 60 is going to be from here to here, and so on all the way up until we get to the top. And then all we do with those little bars that I just made, disconnect them here, go, is drag them back down to the horizontal axis. Drag that back down, drag that back down, and drag them all back down, and we'd be able to make a histogram. So now I just need to give them heights here, give it a height there. I'm just rudimentary in making this, and I'll show you what it looks like better in just a second. So that was kind of the main idea, and then we'd get this picture of a nice histogram. And there you can see a little bit more clearly than you could see in the ogive that we do have a quite symmetric distribution. All right, I'm going to leave you off there today. Remember, on Monday, we have our Chapter 1 test. So be ready to go right at the beginning of the class. Make sure you have a calculator. Make sure you have your formula sheet. Feel free to add your own notes to it. And then on Tuesday, we'll get right back to Chapter 2 information. Have a great weekend. I'll see you on Monday. Adios.